is, I just got these. I found these on eBay and got like a bazillion of them for like super, super cheap. I guess from a teacher that was retiring. They're they're practically brand, yeah, they're like amazingly good. Probably been used like once or twice. Okay, anyway, now I've already have a few of these, but I have 3 and they're junky. So these are not good. So I'm gonna pass these out to you. These are called a spectroscope. Spectroscopes, literally, I'll give you guys the good ones. Spectroscopes give you the ability to see light. And you're like, wait a second, Mr. Hill, my eyes already give me that ability. You're correct. But these give you the ability to see what makes up the light. For instance, am I looking at a true yellow, or am I looking at a red frequency and a green frequency, which makes yellow? This allows you to see it.
I was in the wrong way.
All right, well, I was going to teach you all how to do it in a moment, but you know, these are my old
That's
ones.
really cool.
Yeah, that one's good. This one's good. This is another one. Oh, this one doesn't have anything in it, so that would be a bad one. That one's good.
Really cool.
Oh, I have to. Let it be known for the fact that Josiah is hungry already.
That's not surprising.
There you go.
I'm
There you go. Now, normally, I always make people share, but since you all get since you all share, you get to do your own here and live the dream. All right, so what I want you to do, we're going to practice with it. Now, of course, this is one that doesn't have anything, but that's not a big deal, because I'm using it. Take the spectroscope, it's like a slice of pizza. It is not pizza, do not eat it, Josiah, okay? But it is like a slice of pizza. Just like you eat a slice of pizza, you hold it that way, okay? So take the thin part, you're gonna look through it. Now, when you look through it, you're gonna see a lot of like weird things. Don't worry about it. Stop looking through it and look out this side. There's a little slit right here, not this big slit, not this. The little slit. The light source that you are using when you're looking at the light needs to come through that slit. So when you're looking at something, you look through that slit right there. If you all would real quick, look up at the LED lights. Make sure the light is pouring through that little slit, and off to the right where that weird thing is, you should see a rainbow. Do you see it? I have to ask this because every year there's someone that doesn't know how to do it. Everyone see the rainbow. It should be a continuous spectrum. Because believe it or not, LEDs are like incandescent bulbs, but not. They're diodes, but they can work that way. What I want to show you today is that not all light is truly the real deal. I need to get a rag. Yeah, the numbers represent the nanometers. So if you have like one, it's like it'll be anywhere between like 400 to like 700. That's the nanometer spectrum, so you can see exactly what's going on.
Really? The lights come through.
Yeah, but
I'll do it here.
When I look through eyesight, there's
Yay! All right, everyone, put your spectroscopes down.
You need
You mean that just disobeys me directly? All right, here we go.
it?
Do not use your spectroscope. I'm going to lift it up, don't worry, okay? This is a lamp. I brought it from my house. This is literally like by my wife's like nightstand, okay? So it's not a bright lamp, it's just a standard lamp. So just looking at it with your normal eyes, what color is this lamp?
White.
White, yeah. I mean, I hope if someone says it's not white, yeah, okay, like it's just white light. However, this is a compact fluorescent. What I would like for you to do now is use your spectroscopes, make sure the lights come into the side, and look over to the rainbow and see what you see. You will notice it's not a continuous spectrum. At least you should notice that. Can you see it?
It's RGB.
Yeah, I think you'll definitely see RGB, but I think there's an extra band in there too.
Oh.
Like an orange or something like that maybe. I know there's a blue for sure.
It's a purple. Oh, it's
Do
pretty.
you see the little lines? Like you'll see the full, but you should see like bright spectra lines. Like you should see an emission.
Yeah.
Do you guys see it?
Yeah.
Okay, if you don't see it, it's okay to say you don't see it. Just let me know. If you don't see it, let me know you don't. Okay,
I don't know.
what color? You did not see it?
I don't know what I'm supposed to see.
When you look through it, let's set this down. When you're looking through the oh man, this board is a mess. When you look through the spectroscope, you're gonna see this, right? It's gonna be like this. The light should be coming through this little slit right there. That's where your light is coming through, okay? Over here, you will probably see a band here, maybe a band and a band and a band. You should see like, I think that's what it looks like. Honestly, I haven't even looked at it, so I'm not sure. Can I borrow yours real quick, Mike? Because this one is a specific one that I got. Oh, nice. Yeah. So you should see, actually there's 5 bands in this one. So I can see 5 bands. So you'll notice like there's definitely a red, there's definitely an orange, and it looks like there's like 3 in the bluish area. There's one at the far end of the blue, one in the middle. Like you'll just notice it's a little bit more bandy. It looks a little weird to you though, because the compact fluorescent has multiple like light pieces, and that's why you're seeing that little bit of an echo, because there's multiple light things, because it's compact fluorescent. Everyone see it now? Susan, you got it?
Yeah.
Are you just saying that, or do you actually see it?
Yeah.
Okay, I'll take it as a yes. Okay, now let's compare that. Okay, looking at it again with your standard eyeballs. I'm sorry, it's so bright, I know. Oh, Emily's like, my eyes are broken.
Yeah, they are.
Okay, now this came from my house literally today. Now, let's see what I brought from, ooh, I think this one's like that. One of these is janky and it buzzes. Makes me happy. Probably very dangerous, but. Is it this one? Ooh. All right, take a look at that one in the spectroscope.
Oh, I like that one. You can kind of see the light itself.
Do I need to lift it up a little bit? I got you.
Keep it warm.
Oh yeah, that one should be like crystal clear. It's not as bright too, so you should see those lines very clearly.
Yeah, like a green.
You see them?
A little blue and a little green.
Yeah? You guys see it? Okay. Basically got the same lines, but they're shifted a little bit. What do you also notice about this color? It's still white, but what do you notice about it? It's more of like a warmer yellow, meaning there's a little bit more red or orange yellow to it. Okay? What I'd like you to do on your sheet, the one that I gave you, which I told you that we're not going to get to at the very end, back sheet, there's a thing that says compact fluorescent. I think you'll see like a grid that says compact fluorescent. Go ahead and label what you see. I'll hold this up. You can keep looking at it and just label it. You can later go back through with colored pencils unless you're already over prepared and you have those now. Just put like little lines where you see them and then label like this is red, this is aquamarine, teal, whatever color you want to say. Baby blue, light blue, dark blue. Guys will say light blue, dark blue. Girls will be like teal, aquamarine, whatever you say. Sky blue. By the way, if you are using your camera, it's probably, oh, Ian's already doing it. I was gonna say, you can probably do it with your camera too. It might take a lot of extra effort, but.
I got it on mine.
You did get it?
Yeah.
Nice. Okay, so if you wanted like a special photo or something like that, it does work. It just takes a lot of work. Claire's like, I'll just let some other person work through it.
Oh my god.
Nice, kinda cool.
Orange and red.
Yanina, you're looking way too high. You were looking up there.
Why is it so much red? Orange and red.
All right, we good?
Oh, hold on. Hang on.
Baja Blast.
Baja Blast.
Baja Blast.
Oh, true.
I see red.
This is the time for open house, and I want someone to just barge in the door. I'm like, what are you all doing? I'm like, we're part of a cult. Staring like,
You want to draw it like that?
It looks like the one.
ideally, just pretend that that big rectangle is that thing right there. You don't have to do the small thing. Just use the big rectangle as if that's the part you're looking at. So you can just do the whole thing.
So I saw.
Yeah, I mean, however you want to do it, Emily. I really don't care. I just want you to understand what we're doing. Isn't that weird though? Do you know why compact fluorescence? Do you know why? I'm sorry, Graham, I didn't realize you were still up.
No.
Do you know why they only give off these colors? What's in a compact fluorescent bulb or a fluorescent bulb in general? Not these are LED. But what's in a fluorescent bulb? Have you ever thought about it?
Some sort of chemical.
Well, chemical is a very loose term, yes, but what's in it? Gases of different things. Okay, I'm gonna tell you this right now. The blue line that you see, do you know what makes that blue line? It's the reason why they don't like compact fluorescence, and the reason we moved to LED. Compact fluorescence, to get the blue, so you get the RGB to get white light, the blue comes from mercury. Mercury gas is inside of this. Now, when I was a kid, I used to play, well, I better take that back. When I was a kid, when I was about 16, I worked for a company called Burrs Logistics. Graham already heard about all this already for the other class. When I worked at Burrs Logistics, and I had to change the light bulbs in the building, and they were all fluorescents. And when we were done, I would play with the broken ones like they were lightsabers, and we would throw them into the dumpster, and then we watch them shatter. There's a reason you're not supposed to do that, because you're actually releasing mercury gas every time you do that. Highly toxic, not a great thing in the world. The other colors are caused by krypton. There's probably some neon in there. We'll look at some of those in a moment. But anyway, make sense? Yes? No? Okay. Josiah said no, so I know I did a good job.
Could you put the white light bulb back in
The
so I
bright
can?
one?
What?
The bright one?
Yeah, the original one, so I can get the special photo of that.
Can I switch it to another one that's not as bright? Because I think the over brightness made that one hard. Let me try this one.
Okay.
This one I think is slightly different. It might be the same, so I'll find out in a second.
But I was looking at the side.
I have 7 colors. Different colors.
No, that's about the same as the other one, isn't it?
Yeah.
I'm trying to find different ones. So the reason that you can change the color of the bulb is simply based off of what gases you mix together with that bulb. I did that one, that one. All right, I'll try this one again, Ian.
Okay. Thank you.
This one's gonna be bright though, so you might have to change your ISO settings, or your camera might do it for you. Woo! Bum, bum, bum. How we doing? How we doing?
It's like red and green and blue. It's like 4 colors.
Did you get it, Ian?
Almost.
Okay. I know it's just really bright. That's what makes it a little hard. I feel like I'm a star. All these stargazers looking at me. I wonder how the stars feel when people have telescopes pointing at them. Stars are not living things. I'm just throwing that out there. Just.
You know that one lady in the Columbia picture or whatever, or something, that she holds the light like.
You know, Ian, we can take a photo off the video. Take a screenshot.
I see red, orange, 3 shades of green, and indigo. You see yellow?
All right, Ian. If you don't have it in the next 30 seconds,
I got
I'm
it.
taking it off.
I got it. Thank you.
Oh, good. Who cares about everyone else? I'm joking. Everything I'm doing is on video. You're gonna be like, Mom and Dad, I get bullied at school and I have proof.
Are you ready?
Are you writing that down? Yes, please write that down. Mr. Hill bullies kids. All right.
Mr. Hill.
All right. This, if it works, I can't remember if this is the working one. It's gonna hurt. It's gonna hurt. Oh, it's not. It is. This is an incandescent light bulb. What do you notice about the incandescent light bulb?
It's
It's calm.
it's continuous.
Do you know how incandescent light bulb works? It's heating a wire. There's no gases involved in an incandescent. Compact fluorescents have gases, so you have to mix the right mixture of gases to get the RGB that you want to get white light. Incandescent, it's continuous. But there's a reason why you can't buy these anymore. During the Obama administration, they made it illegal. That would kick in at a certain point. And now you can't buy these. There's a reason. Incandescent light bulbs, while they are bright and while they've been used for many, many years, it was the first, like, Thomas Edison made the first version of this. The reason we don't do it is this incandescent light bulbs have a problem. While they're beautiful, they use a lot of energy, and most of that energy, about 90% of that energy, is not light. It's heat. Wow. They use these for like chickens, like when you're growing like chickens and eggs in an incubator, they give off heat. Okay, so these are actually better heaters than they are lights. That's why Obama pushed away from it, because LEDs can give off the same amount of light, and they still are a continuous spectrum, but they barely use any power. If this is a 60-watt bulb, an LED bulb of this caliber, this bright, take about maybe 5 or 8 watts, right? So 60 versus 5 or 8, right? The 5 is what you're gonna go with. By the way, that also means that it's 5 watts. You can use a USB port to power an LED light bulb that's this bright. Okay, now do they make those? I don't know, but you could, realistically. And if you don't believe me, look at the little tiny LEDs on your phones. Okay, all right. I guess I got rid of Sparky. It was the compact fluorescent that was like one of my faves. All right, any questions on that? Yes, no? We good? Okay, now what we're gonna do, and listen, you can call me cheap. I just consider myself to be a person of, what's the word I'm looking for? Not yet. I consider myself to be a person of shrewdness. I could have bought all of these lamps. I choose not to, because each of the bulbs on these lamps is like $75 to $125. And I could just show you a video of someone doing what you guys just did. You guys have had the experience with the spectroscope now. You've used it. Now we're gonna look at someone else doing the same thing through a diffraction gradient. And before you know what I'm talking about, a diffraction gradient is this. It's clear, and it's what's in your spectroscope. When you look at it and you look at light, you'll see rainbows. I'll pass this around if you want to, but if you look outside, you'll see the full rainbow. If you look at compact fluorescent, you'll see the different lights that make up the fluorescent. So I'll pass this around. Try not to get your hands all smudgy on it, but I'll pass it around. This is already in your thing in the spectroscope. Okay, but what we're gonna look at in the video here is finding that exact same concept with lamps that I don't own. And again, instead of me spending like $600 getting all this, we could just, I don't know, watch the video. It is, because the TV is made up of. All right, what am I doing? Oh yeah. Yeah, there we go. That wasn't what I wanted. Darn it. Yeah, here we go. All right, one last thing. I always include this every year. If it makes it in a lab notebook, that's awesome. If someone ever leads out a conversation with you with the following 2 words, you should always run away. This guy's a nice guy. He's older. But like, just being honest, if you hear this, don't ever, no, just don't. Okay, so let me share it. Yay, here we go. Not this, this is.
This one happens to be.
Oh, I cut off early. All right, let's go back.
Or, excuse me.
Go away, go away.
Okay, kiddos, today we're
Okay,
gonna-
kiddos, never take that word, that's bad.
Excited hydrogen, helium, mercury, and neon. And we're gonna look at them through diffraction gradients. I'm gonna try to place this over the.
Oh, you
lens
don't
of the
need your
camera.
spectroscope anymore.
This one happens
That's a
to be
gradient already.
The atomic spectrum, or excuse me, the visible spectrum for hydrogen gas.
Okay, so taking a look at hydrogen. Hydrogen has a nice solid red peak and a nice solid blue peak. Now you may ask, Mr. Hill, I thought you said we use mercury in compact fluorescence because it gives off blue. Why don't we use hydrogen? Anyone want to take a gander at that one? I mean, it's in a lamp, it's fine.
Because it looks like this in the red.
What happens if hydrogen leaks out of the bulb and there's a spark?
Flammable.
Mercury doesn't do that. Helium and some of these other ones don't. So we use inert gases, not hydrogen. So yes, this is a real lamp, right? But like we wouldn't do that in mass consumerism for danger, just throwing that out there. Anyway, if you look on your thing, there should be a hydrogen. I think it's on the first page somewhere. There's one that says hydrogen. Go ahead and fill that out with the red and the blue. I'll play it in a second. All you're looking for is the bright parts that you see in the spectrum. Okay, and again, you don't have to worry about necessarily taking a picture of this later. This is more for reference. So when you do your lab notebook, if you want to, beautify it or redo it on your own or find an image on the internet that matches it, that's fine. Okay, but at least for today's lab, I just want you to see the differences.
That was for hydrogen, right?
So Niels Bohr, when he's first looking at things, he notices that hydrogen has two different wavelengths. Remember, what did Niels Bohr say that was from? Atoms being excited. We're running electricity through it. Atoms getting excited, and what are they doing? They're going from a high ground state to an excited state, and we see the light when it goes from excited state back to ground state. And these are the specific frequencies that we can see. Now you may think, oh, is that it? No. Some different gases release ultraviolet, some infrared, but we can't see those things. And because we can't see that, we don't go through it. Have you ever been to, ready? Pump Up Fun Center? Have you ever noticed that a black light bulb, like they call it black light, how it gives off UV? Would you like to know why? The gas that's in it releases spectra in the UV. We can't see it, but we can see the reflection when it reflects off of something that absorbs UV and releases visible light. All right, I'm gonna keep moving.
You can see we have some nice sharp lines there. And as I do this, I'll rotate this for you so you guys can get a good view. Remember what those lines are. They represent electrons dropping from a higher energy to a lower energy. And when they do so, they give off a certain frequency or wavelength of light, which has a certain energy. And we can calculate the value of the energy levels in the hydrogen atom. Of course, Niels Bohr decided to use hydrogen first because it only had one electron to worry about. And he figured if he could find out what happened with one electron moving around the nucleus of an atom, he could extrapolate that to atoms with many electrons. So that's hydrogen gas. I'm going to go ahead and switch this off quickly, and we're going to go to, I believe we have helium next. So switch that up for us.
Oh, look at all the pixels you guys get to see.
Okay, so turn that on. There's helium. And we'll do the same thing with our diffraction gradient. We'll place
It has to
over
warm
the
up a little
camera.
bit, just so you
See
know.
if we can get a nice visible spectrum there. That looks pretty nice, doesn't it? So you can see.
This is probably the best one that I'm seeing right here out of the group. I mean, they're all here, but right here is probably good. Look at that red. It's not even like a, it's like, what is that? Ladies, is that burgundy? Is that the color? Thank you. Again, I don't know these things. Burgundy, I just try to translate what my wife would think. Yellow, look how bright that yellow is. Does the color that you see in the middle remind you of anything? Does this color remind you of everything? Have you seen that color before? The sun. Yeah. The sun is hydrogen fusing to make helium. So we get that bright yellow line. And it releases a bunch of blues there. There's a blue here, a blue there, and a blue there. So teal, almost like a indigo. Indigo is what I was looking for. And then like that, but that's fine. This is what it looks like. Use whatever it is. If you're guys, just say not bright red, bright yellow, and 3 different types of blue. That's fine. and light yellow, light blue, blue, and blue mixed with something else. Kind of cool, right? Who knew? Apparently, Piper already knew. Oh my goodness. All right, everyone good on this? I'm gonna play it.
We have a different set of lines for helium. Might be interesting to note that helium was first discovered not here on Earth, but on the Sun.
I mean,
Let's
what do I do?
think about perhaps
I
how
just
that
let
was
this guy
done. And using a similar thought process as we're using today. Notice the spectral lines are different, signifying we have different values for the energy levels as the electrons are moving around the helium nucleus as opposed to hydrogen. So once again, that is helium. Okay, let's switch that out and we'll go to mercury vapor next.
Mercury. But yeah, you can use these as a fingerprint, at least for some smaller
Turn mercury
elements.
vapor on.
That's kind of cool.
And we'll put our diffraction gradient.
Ooh,
We certainly get a different spectrum there with mercury vapor, don't we? So. we have
I'm
a lot
looking
of
for a good
purples.
one.
We have that nice sharp green.
All right, that's probably the best one. You can see there's a little hints of red, but it's really not. It's this green, green, and then that blue. You can kind of see the same thing over here. It's blue and green, green. It's probably the best one. The blue though is a really rich blue, which is why we use it in compact fluorescence. Again, LEDs are gonna be the way of the future. Most companies have changed, like our school did it too. We used to have fluorescent light bulbs. And when Pap was here, you guys remember Pap? Yeah, when Pap was here, he really pushed the school to invest in buying LEDs. And it saved us a lot on our electricity bill. Yes, it cost a lot of money at first, but with the electricity bill, we've already made that money back. Because LEDs use so little power, and they also give a better color, and they don't flicker as much. They still flicker. We'll talk about that later. They don't flicker because of the fluorescent, but they flicker because LEDs only work one way. When the electricity goes one way, they can work. They're a diode, but the other way it doesn't. So if you ever use your camera and put it on slow-mo and watch a video, you'll notice this room flickers. And maybe we can do that after this if you guys want to. I'd like to get the flame test though, so we'll see what happens. But if you put slow-mo video in this room and you're watching someone, you'll see the lights flicker 60 times a second, because that's what we do in the US. Okay, moving on.
Spectrum there, or that green color there that's visible. And all I'm doing is I'm rotating the diffraction gradient so you guys can get a good view of what's happening here. Okay, that's mercury vapor. Let's do one more. We'll go ahead
Our
and do
favorite
neon
one.
next.
Neon.
Of course, that's everybody's favorite. Put that in there.
I just said neon.
That's fine, and I'll turn the neon on. And we'll go ahead and put our diffraction gradient. And we'll see, once again, a different series of lines. Oops, let's put that right over so we can see that a bit better.
Yeah, that's probably a good spot. Like a red, almost like a pink red, right? But it's red, but then orange, orange, orange. Neon was the most famous one commercially because it was bright and it was red. It gives off a nice hue. So back in the day for signs, everyone, as weird as it is, science normally always leads to people over advertising or capitalizing on science. So when neon was discovered as something you could run electricity through, people made neon signs. They're bulbs of glass filled with neon that you run electricity through. If you ever want to see a bunch of neon signs, go to Texas Roadhouse on Ward's Road. That place is loaded with neon signs everywhere. Who uses it? You'll see Coca-Cola. You'll see all the beer companies, Budweiser, Miller. They all use neon because it was a cool thing, and people spent a lot of money on it. Nowadays, you can do the same thing with an LED. Like the one we look at the school, when you walk into junior high, you know they have the educating, like our motto in the neon. It's not real neon, that's just LEDs. But that concept of neon lighting was huge for a long time. It has since lost its thing because it was overused. So open signs used to be neon, right? And so neon was used the most. If you see neon signs, like if you go to Texas Roadhouse, you might see green, you might see some blue. They just mix different gases in different chambers to make those colors. Sometimes they mix them, sometimes they keep them separate. All right? Any questions, comments, concerns? Does this make sense? Was this helpful? Okay? All you're doing is exciting electrons, and this is what they release. I'm assuming that there's more that's released in this side on the infrared that we can't see. Because neon signs also give off a little heat, right? Which infrared we feel as heat. Cool. I think that's it. That's it. That's the end of it. And then it just goes back to that, which is the normal bulb. All right. We all good? We all happy? Yes?
Yeah.
Cool. If you would like, you can take a quick break with your phones if you want to stop that video file. And then we'll start the second one because I got to prepare for it. And so when I go to do that, I need some things moved. I don't want it to be too disruptive. So if you guys want to, go ahead and stop your video. And then we'll get ready for part 2. Sorry for lunch.
I know, me too.
All right, kind of cool, right? Something basic? All right, now what we're gonna do today, and I've gotta clean up some things. I had traffic duty, and I tried to get here in the morning, and I knew it wasn't gonna work, and it didn't. So, it's all right, I can still get this done pretty quickly. What we're gonna do is we are going to do a test, and I'm gonna explain the test to you in a moment. Don't worry, you don't have to record yet. I'm gonna explain the test to you, and what we're gonna do is we're gonna burn things. I need to warn you in advance. Everyone's gonna get a chance to burn, but I do need and again, I'm gonna cover this in the video, so you're good. I do need to warn you that there is real danger to this lab. I've never had any incidents, but there is real danger. So please, when I go over the things, listen to me when I go over it, okay? You will also need to get lab coats. So at this time, now listen, because I'm not sure how many she's got over there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If there's 12 over there, that's great. If not, just find like a partner or two and you can swap lab coats back and forth when you go to do it. Okay, ladies, I think all of your hair, Claire, Avery, you'll have to like, do you have like a tie with you or something? Claire! If you have a spare that you want to use, if not, I can get you a rubber band, but that's gonna hurt. So, listen, I've almost had a kid's hair catch on fire before.
I set my hair up.
By kid, I mean someone your own age. Actually, she was older than you. It's even worse. Jenny Nolan. Good. Colin, your hair, you have to pull back. Looks good. Yeah, Jenna, I'm sorry. You might have to pull it back. I've never seen you in a ponytail, Jenna. Unbelievable. I love how, Emily, don't laugh at her. Also, you guys can use this time to, where I can look at your things real quick too while I get everything set up. Can you guys get up? I need to move the table. What does it say? If you want to put it on that top table right over there. You don't have to record this one. Oh, sorry. What are you doing? Ian apparently wants to keep recording.
How much storage do you have on that thing?
Hey, that 40-minute video was pretty high quality. Not gonna lie.
It's already at
use that in
33.
the future for people that didn't get to watch the lab. If you're okay with that.
Are you at
Yeah.
0.5? Wait, what was
I saw that. A picture.
Thank you, Dan. I've literally just cleaned.
You took like 3 pictures. You definitely sent one to me. What was your story, bro? What about Ian? Have you seen some of Ian's pictures? I have. Oh my goodness, he takes the way.
Funny.
Wow, that was.
You have to use a rubber.
Which game? A bunch of those. Friends versus Racing.
Yeah, actually,
I can check my bag.
Alright, where's the brown? See, I literally see it. Yeah, there it is. You beat me. That's so impressive. Oh yeah, this is the great game. You won? No, look at the accuracy.
I just failed as.
No, I won with 26% accuracy last night. This is like a 700 something game.
Oh, you could! Wait, that actually might work. But I'll do a pencil back. That actually might work.
This is the one that was 20.
It
It was literally an 887 game. And we played at a 150 and 100 level.
On the road.
no.
My favorite is when I see I got 4 builders in one game and I still win.
Okay, cool.
I was like,
No, it's good. No, I think actually can find it.
Wait, how is that?
I took something there so that I could pin
It's fine.
I took like a night between takes. I pinned the queen.
Why are you filming this?
I have that trade and I win it too.
You can press it.
Because I traded
Make it
Let's try. Full sack press midnight. And then that one I need to go
I used to too, but I put them all on my side and then I put them around the yeah, can you do
My goodness.
Absolutely.
Reaction. Hey, do you have like no pictures between my slide and this slide?
You messed up my camera. Good.
Serves you right for.
What did you do? Graham did it.
I did that.
Colin,
Yeah.
I got one.
Gosh.
I am mad.